about morphologic image processing. It's a very simple topic, but it can be very useful when you wanna process an image. This morphologic image processing can be done as a pre-processing step or post-processing step for a big project. Okay. First, I will introduce some basic concept, and after that, review the four important operation, and with the some notes of MATLAB about how to coding, how to use the these operations, and in the end I will introduce my my project for MRI image to lung cancer detection, and I will introduce the morphological operation to improve the result of the segmentation for the lung. Mathematical morphology is a tool. It's a tool to extract the image component. It can be, as you can see in the picture in the right side, the image and the boundary of that and the skeleton of images. It's important to processing the images, and the basic concept of morphological image processing. It's used the set theory, and suppose we have an image as an input, and we have another structuring element that define the neighbors, and we thinking about the images as a set and the structuring elements as another set, and we do some processing by these two elements.
What is the meaning of morphology? I'm missing that word.
Really, it's depend on the geometric of the images. If I wanna roughly say, it's something that you only use the geometric in the images. For example, you use the neighbors of some points and make a decision based on the neighbors of each point.
Okay, so that is morphology.
Yeah.
I think morphology, which is not very clear. The meaning of morphology means you are getting some shape, but it is not very clear. Is it something that?
Yeah, it's similar to this. Yeah, and we can define the neighbors by this comment in the MATLAB structure element, and we can use the shape and parameters. For example, here it's some of the neighbors, and that in the MATLAB really we use the matrices. The gray points are, for example, 1, and the white points are 0. These are some samples that you can use in your MATLAB code. For example, this one is this with radius 3. For example, you can write here as a shape this and the parameters 3, and it creates some matrices like this for defining the neighbors of each point. Here the center is here, and this area shows the neighbors of this point. As you can see here, we can define different type of the neighbors to based on what we want to do on images. We have four types of operations. First of all, dilations. Here we have an input image, and based on neighbor of this image, if we have a binary image, we search on the neighbors, and if we want, if we find only for at least one non-zero element, the input of the pixel will be 1, and in the images for different level of different grayscale level, the maximum of the neighbors will be the value of the center point. The if you want to put the IM dilate, I as an input and SE as a structuring element, can do this work for you. Yeah, it's format. Yeah, and here's some example. For example, if you have a square with D by D and you select B as a structuring element with the size D by 4 to D by 4, the output result is something like this. As you can see here, the D over 8 extension or dilation will be added to the original image, and the operation that's ordinarily used in the, for example, if you want to write something in the mathematics, the plus sign, a square in the middle plus shows the dilation, and it has and another example here, a neighbor D by 4 to D, and the result extend in the D by 2 in top and bottom, and D by 8 in left and right. And another application of dilation can be, for example, in the text. As example, the text with this neighbor, if you apply the dilation, the result will be something like this, and it's easy to read for you. The second operation is erosion. Here, the meaning of erosion, if we have a binary image and in the neighbor we have at least 1 0, the result will be 0 for the origin, and if we have a multi-gray level, the minimum of the neighbors will be the value of the center point. If you wanna use this operation in the MATLAB, IM erode, the I is the input and SE is the neighbor. Same as the previous example, if we have a square D by D and we define the neighbor D by 4, D by 4, the result will reduce the margin by D by 8, and the output square is 3 D by 4. And for the second one, as you can see here, it's reduced by only a line in the middle, and the operation is a square in the middle minus. Here, example, it's a binary image. That's we define the different type of the structuring elements: 11 by 11, 15 by 15, and 45 by 45. This one is for 11 by 11. Output result of this is the original one. This is 11 by 11. This one is 15 by 15, and the last one is the 45 by 45. And you can see, for example, in 11 by 11, there's some strong line still exists, but if you extend the neighborhood, the line is small line will be disappear. Based on these two elements, dilation and erosion, we define two next operation, close and open. Meaning of close and open is, for example, first we do a dilation and followed by an erosion. It means first we extend and after that we reduce the area, and if we do this operation, the output is fill the holes in the image. You can see here, for example, here based on the neighbors, here is a hole, and the close operation will fill this area. As you can see here, this image, the area hole is smooth now, and the operation will define by a dilation and after that erosion. And open operation, it's erosion followed by a dilation, and it's remove the spike or the sharp points of the object. And here it's the summary of the operations. If we have this shape and we define a neighbor, this neighbor, for example, by 1 pixel, the result of erosion A by B will be this shape. It's remove the middle, and you can see it's useful for find the skeleton of the shapes. Dilation, this is the result of dilation. On the erosion image, as you can see here, the middle one was disappear, and you apply a dilation on the first image, it's remove the small part of the image, and it's the result of opening. And if you do a dilation and after that erosion, this result must be closed. This is some examples. It's original image, and result of 4 different operations: erosion, dilation, opening, and closing. And here it's real usage of morphological filtering to reduce the noise of a fingerprint and find the skeleton of a fingerprint. As you know, in the fingerprint, the point of the lines are discontinuous or they are branch are very important, and finding this point in the original image is hard. But if you use the morphological operation and find the skeleton of the fingerprint, finding the branch point or discontinuing the line, it will be easy. based on your application, you can use the different sequence of the dilation and erosion to find your best result or reach to the images that you need you need it. This is the original image. It has some noise. It's in this application first erosion remove the noise, but if you do the erosion on this image, you will lose the lines of fingers, and after that you can do a dilation on that, and it's improve the lines. Again, doing the dilation, it's will remove the small discontinuity in the lines, and it's make lines continuously. For example, here you can see some discontinuity, and if you do again dilation, it's fill the space between the points, and after that closing, it's will smooth the output result. This part was the first part of introduction of the operation in the for the morphological filtering, and this part the start of my work. In our work we need to extract the area of lungs, and first of all we can do a color segmentation in the color space, and as you can see here we have some noise here, the point black here and some white point here, and we can continue. For example, we can reduce the noise by a medium filter. It's improve the quality, but we have still some white point here. And the reason that we need the original image of the lung here is because in the boundary of the lung and bones or the other tissue of the body, it has some strong changing. In our work we need to detect the cancer, and the area that the lungs goes to the body is not important for us, and we wanna find something in the middle of the lung that it's anomaly and it's cancer. Because of this, we need to extract the area of the lung, and after that apply our classification techniques to classify the each area of the lung. After doing the medium filter, you can see still we have some points. Here we can do image erosion, and by this work, if we use a disc one, it means we use only a neighbor one around each pixel. We can reduce some points, and again we can apply the medium filter. You can see some points are disappear, and by dilation again we have the original size of image in boundaries in middle, and we can do this work with different disk size here with the disk with the radius 2, and after that medium filter, and again dilation keeps the area of the lung in the same size, and we can do with the bigger disk size and median filter, and here you can see the area of the line is clear completely, and if we do a median filter, we remove all of the noise in the line, and if we in the last part, if we do a dilation, it's the area that we need for improve the result of segmentation. This is the result of it. This is the original image, and this is the segmented part of this. As you can see, it's the good match between the boundaries of the body and the lungs. If you have any question.
If you need more material, okay, have a text note, have this one with exercise.
Really, I applied in the images for the MRI